Welcome back to the deep dive. We're here to really get into the source material and pull out what matters for you.
That's right. Today we're carrying on with Semantic Kernel. Got a review here, some notes,
Huh?
looking at part 2 of the core ideas.
Yeah, part one, for those who joined us, was all about, the setup, getting SK running in Python, hooking it up to an LLM, a little bit on plugins too, just dipping our toes in.
Gave us that essential grounding, I think, the
Yeah.
basic architecture.
Absolutely. So this time, we're zoning in on something really crucial based on these sources, Semantic Kernel's AI services. It's really about how SK works as that flexible hub connecting to different models, different AI capabilities, managing it all.
Yeah, it's the backbone, isn't it? How your app actually talks to the intelligence,
Yeah.
the communication layer.
Exactly. So the mission today, unpack this material, understand the core concepts, and see the practical steps for actually using these AI services in Semantic Kernel.
Okay, let's dive in.
All right, so where do the sources kick things off? Environment setup.
Standard starting point. You need your Python environment configured correctly. No surprises there.
Right, getting the tools ready. So importing packages, what are we seeing here? Things like OS, I assume?
Yeah, OS for environment variables, definitely.
Okay.
And core SK stuff like kernel, chat history,
Okay.
stuff we saw before.
Okay.
But interestingly, the material points out some newer classes, specifically for handling, well, different types of chat content.
Oh, like what?
Things like chat message content, text content,
Yeah.
but also image content.
Ah, image content. Okay, so straight away we're seeing hints of going beyond just text messages. That's interesting.
Exactly. It sets the stage for richer interactions later. And then, the usual configuration,
Yeah.
connection details for your AI service. Azure OpenAI is the example used heavily here.
So deployment name, endpoint, API key, that kind of thing.
Precisely. And the source is really, really stressed using environment variables for this.
Which makes total sense. Why is that push so hard here?
Well, it's mainly security, right? Keep your API keys and secrets out of your code. You don't want to check those into Git.
Definitely not.
And flexibility, too. Makes it easy to switch configurations between, say, dev and prod or even different models just by changing the environment. No code changes needed.
Okay, environment's prepped, secrets are safe. Now, the main event, getting these AI services actually into the kernel.
Right. So first you initialize the kernel itself.
Okay.
Kernel. We saw this last time. That's your central orchestrator.
The conductor managing everything. Got it.
But a conductor needs instruments. So the next step, and it's a critical one, is adding an actual AI service to this kernel.
Okay.
The sources use Azure Chat Completion as the main example for a chat model. You create an instance of that class, feeding it the specific connection details for your deployment.
So you're basically telling that specific object, here's how you find and authenticate with the actual AI model running out there.
Exactly that. And a really key point from the material is assigning a unique service-side when you do this. Something clear, like Azure OpenAI Chat.
A service-side. Why is that identifier so important? Does it do more than just label it?
Oh, absolutely.
Right.
It's fundamental, really. Imagine you want to use multiple models. Maybe a powerful one for complex chat and a cheaper, faster one for simple tasks. Or maybe even a model from a completely different provider.
Ah, I see.
That service side is how the kernel tells them apart. It lets you specifically request, say, the complex chat model or the simple Jana model later on.
So I could have server-side GPT-4 chat and server-side GPT-35 summary or something.
Precisely. It gives you that explicit control. So you configure the service object, give it that unique ID, and then you just add it to the kernel using kernel.addService.
Template.
Yeah, the analogy in the source was quite nice. It's like telling your orchestrator, okay, here's your star vocalist. Use them when needed.
Okay, so the services are added. The kernel knows about its vocalists. How do you actually, use them later in your code? You need to retrieve them somehow.
Right, and SK offers flexibility here too. One way is retrieving by type.
By type.
Yeah. If your code just needs any chat completion service, and doesn't care if it's Azure, OpenAI, or something else, you can ask the kernel for it generically. Like kernel.getService, type chat completion client base.
Okay. That sounds good for writing more adaptable code, doesn't it? Less tied to one specific vendor.
Exactly. Promotes portability. But maybe you do need a specific service. Remember that service ID.
As you reopen a ship. Yeah.
You can use that to grab the specific service you configured earlier, kernel.getService, as a reopen it.
Ah, perfect. So if I do have that GPT-4 chat model and a code-dredgen model, I can explicitly ask for the one I need for a specific task.
That's precisely the use case. This choice between retrieving by general capability type or specific instance ID is really core to how SK manages different AI tools effectively.
Makes sense.
The sources also briefly mention you can check the type of the service you get back, just to be sure. Simple validation.
Now, here's something interesting the sources brought up. You don't always have to go through the whole kernel orchestration for everything, do you?
That's right. It's possible to use the chat completion service object directly, once you've configured it, without involving the kernel.invoke prompt machinery we saw before.
Okay. When would that be useful? Why bypass the kernel?
Well, the material suggests it's good for maybe simpler single-shot interactions. Quick question, quick answer, where you don't need the overhead of managing history or function calling through the kernel.
Right, less complex workflows.
Or maybe you need really fine-grained control over just that one call.
And how do you control the AI's response in that direct interaction?
Through execution settings. The sources point to OpenAI chat prompt execution settings. This lets you tweak things like temperature, how creative or random the output is.
Yeah, the creativity knob.
And top, which is another way to control sampling, or max tokens to limit the response length, all the standard LM controls.
Okay, standard fine-tuning. And when you make that direct call, how does the answer come back?
Two main ways shown in the examples. First is non-streaming. You send the prompt, wait a bit, and get the entire response back in one go.
Like the example asking for a story about red pandas.
Exactly. You ask for the story, and boom, the whole 3 paragraphs appear at once. Good for when you need the complete thing before displaying it.
Simple enough.
The other way is streaming. This is often much better for user interfaces.
Ah, because you see the response appearing gradually.
Precisely. As the AI generates the text, it sends back little chunks, token by token. So watching that red panda story, you'd actually see it being written out word by word almost.
That feels much more interactive, definitely. More responsive.
Yeah, users don't feel like they're just staring at a blank screen waiting. It feels much more dynamic.
Okay, moving on. The sources seem to really emphasize this next part, handling what they call rich messages in the chat history.
Oh, yeah. This is where I think Semantic Kernel starts to show some really unique power for building, well, more advanced applications.
Rich messages. You mean like that image content class we mentioned earlier, incorporating things beyond just text.
Exactly. Think about how we communicate. It's not always just words, is it? We show pictures, we refer to data, we use tools. SK aims to let the AI participate in conversations that have that same kind of richness.
So the AI isn't just processing text prompts anymore. It can actually understand context from images, or maybe data fetched from a tool.
That's the fundamental idea, yeah. SK provides the structure to weave these different data types into the AI's conversational context into its history.
Okay, how does that work in practice? The sources had an example, right? Hotel booking.
Yes, a really good one. It starts simply, setting a system message to define the AI's role. Standard stuff. You are a helpful hotel booking assistant. Provide personalized suggestions.
Setting the persona. Got it.
Right. But then, the user's message. A user named Anya Sharma says something like, I'm looking to book a room. Can you find something like this picture? And crucially, her message isn't just that text.
Ah, here it comes.
Exactly. The sources show that her turn in the conversation includes both the text content and an image content object that points to a URL of a hotel room picture.
Whoa. Okay, so the AI, when it processes its history, it sees the words and it effectively sees the image the user sent. All part of the same message.
That's exactly it. The visual context is right there in the history.
Yeah.
But the example goes even further. It simulates the AI realizing it needs more info.
Like Anya's preferences.
Right. So the AI decides it needs to use a tool, maybe a plugin. This is represented in the history by a function content object, targeting something like a GettySerp Preferences hotel booking plugin.
Okay, so the history now shows system prompt, user text plus image, and now the AI's intent to call a function.
Yep. And then the result of that function call gets added too. Let's say the plugin found Anya's profile. That result may be text like, Anya is a Diamond Loyalty member, prefers king bed, balcony, high floor, late checkout, is added to the history as function result content.
Wow. Okay, so the AI's context now includes the system role, the user's text request, the image they sent, the fact the AI called a tool, and the specific data that tool returned. That's a lot of context.
It's incredibly rich. And the example then shows the AI generating its response based on all of that. It acknowledges the picture, incorporates her loyalty status and preferences, and asks the next logical questions like location and dates. It weaves it all together.
That really drives home the point. It's not just text in, text out. It's multimodal input, tool use, data integration, all flowing through the conversation history.
Exactly. And according to the sources, this ability to manage diverse content types, text, images, function calls, function results within that history is really fundamental for building genuinely sophisticated, context-aware AI applications.
Okay, that hotel example is pretty compelling. It really shows the potential. Let's quickly recap the main points we've covered regarding AI services then.
Sure. We started with the basics. Environment setup, managing connection details securely using environment variables, huge emphasis on security and flexibility there.
Right. Then we moved to actually adding AI services, like chat models, into the kernel instance itself. Using that server-side was key for telling them apart.
Yep. And the flexibility in getting those services back out either generically by type for adaptable code or specifically by ID when you need a particular model.
We also touched on interacting directly with the service sometimes, bypassing the full kernel for simpler tasks, and the difference between getting the whole response at once versus streaming it piece by piece.
Non-streaming versus streaming, yeah. Important for user experience.
And finally, probably the most powerful bit, SK's capability to handle that rich chat history, mixing text, images, function calls, function results, giving the AI a much deeper understanding of the ongoing conversation.
That integration of diverse data into the conversational context is really what unlocks building more intelligent real-world applications, according to this material. It's not just about text anymore.
Okay, and that brings us nicely to the end of this deep dive on Semantic Kernel's AI services.
It's a critical piece of the puzzle, understanding how SK connects to and manages the actual AI models.
Absolutely. Now, next time, we're going to look at another really interesting layer mentioned in the docs. Filters.
Filters. Yeah, those are powerful.
Seems like they let you intercept and modify things as they flow through the kernel pipeline, like adding logging or changing prompts or checking responses.
Exactly. It gives you control points within the AI's processing loop, a way to inject custom logic or observe what's happening. Very useful.
We'll definitely unpack that in our next deep dive. For now, thanks for joining us as we explored Semantic Kernel AI services.
And maybe a final thought for you to chew on, building on that hotel example. Think about it. When an AI can both process visual information, like that room picture, and utilize external tools to fetch data, like user preferences, all within the same interaction, how did that fundamentally change the kinds of intelligent applications we can realistically build? What new possibilities does that open up?
Something to consider. We'll see you next time.